Hi guys, so the last topic we're going to cover is looking at exercise 9G independent events. So the definition for independent events is events are independent if the occurrence of one event has absolutely no effect on the occurrence of the other. So the probability of selecting one is not impacted by the fact that you've selected another. Another way to write this is the probability of A given B has occurred is just equal to the probability of A if there's no conditional probability there. Okay, we know from our previous exercise that probability of A given B is equal to the probability of A and B over the probability of B. Now we know if these events are independent, that means that the probability of A can replace probability of A given B, so they're equated here. It's equal to probability of A and B over the probability of B. So probability of A and B is equal to probability of A times by the probability of B. If the events are independent. Okay, so to prove events are independent, you need to show either this or this. So you need to show the probability of A and B is equal to the probability of A times the probability of B, or the probability of A given B is equal to the probability of A. So these prove independence. Okay. So as soon as a question asks, are these events independent, you need to test whether either one of these ones hold. Okay. So let's look at an example. So an experiment consists of selecting numbers 1 through 10 inclusive. A is this set, B is this set, and C is this. So question 1 asks, are A and B independent? So first off, let's look at the probability of A and B. So selecting the intersection. So intersection, we have 4 and 5 are in both sets. So you got a chance of selecting the intersection there of 2 out of 10, which is equal to 1 out of 5. Okay, that's the intersection of A and B. The probability of A by itself is 4 out of 10, because you've got 4 numbers out of 10 possibilities, which is 2 out of 5. And the probability of B, selecting only B, there's 5 numbers in B, is 5 out of 10, or 1 out of 2. So, therefore, probability of A times by the probability of B equals 2 out of, well, it's equals long working, 2 out of 5 times by 1 out of 2, multiply top by top, bottom by bottom, that's equal to 2 out of 10, which equals 1 out of 5. And there you go. So probability of A and B equals 1 out of 5, which equals, and the probability of A times by the probability of B equals 1 out of 5. Therefore, A and B are independent, as it's satisfied the calculation for independence. So guys, when you get confused, go back to the definition. All independent events are events that if you select one event, it has no effect on the occurrence of the other. So the fact that you've selected something in B does not impact your chances of getting a number in the A set as well. Okay? So question B, let's see if this is an independent event. So are A and C independent? So we already know probability of A is 2 out of 5. see if you can work through the rest to determine whether A and C are independent. So have a pause and have a crack. All right, going through it, probability of C, we've got 4 out of 10, which equals 2 out of 5. So probability of A times by probability of C equals 2 over 5 times by 2 over 5, multiply top by top, bottom by bottom. You've got 4 out of 25. Okay, so that's your probability of A times probability of C. So we need to show that probability of A times probability of C is the same as the probability of A and C. So what's the intersection of A and C? So A and C, we've got 1 is the same, and then that's it. So we've just got number 1, so we've got 1 out of 10 possibility. So that doesn't equal 4 out of 5. So probability of A and C does not equal probability of A times by probability of C. Therefore, A and C are not independent. So the selection of one will impact on the selection of the other. Okay, have a look at a few more examples in your book there, guys. All pretty similar. Just when you are looking for an independent event, determine if it's independent, go back to showing probability of A and B is equal to probability of A times the probability of B. Or use this initial example as well, whatever works easier for you. Good luck.